Hi everyone, welcome to Lab for Biology 2. This week we're going to be doing a pre-lab based on experimental design, but of course first we need to go over laboratory safety. The same as Biology 1 last year, we're going to scan this QR code to read the lab safety policy. Once you have read the policy, you need to sign and date this document. We're going to look at Mr. Bones or Miss Skellington because my class thought that Mr. Bones looked very feminine, but in the quiz he will be listed as Mr. Bones. So if there's any questions about this activity, this is what we're referring to. So we're going to observe Mr. Bones. This is our lab assistant today, and we're going to be observing and seeing if there's anything that we need to fix about this picture. What is he doing wrong and what is he doing right? The first thing that I noticed is his long, beautiful hair. He has very beautiful hair, but it's not tied back, which means that this could get inside chemicals or it could catch on fire, especially this synthetic hair. It just kind of melts and then sticks to you. So if this melts on your skin, it can cause really strong burns because that plastic sticks. The other thing that we notice about Mr. Bones here is that his eyes are completely covered by his bangs. We never want to cover our eyes and obscure our vision with bangs, hair, hoods, or dark sunglasses in the lab. We want to make sure that we have complete visibility. Speaking of our eyesight, we do want to protect our eyes. So one thing that Mr. Bones got right is that he has goggles, but he's not using them properly. They need to be down on his eyes, which of course now he looks like Cousin It with all of his hair. But ideally we would not have hair in our face, and then we would put the goggles on to protect our eyes. The next thing that we notice is a lab coat, which is okay. Lab coats are not necessarily recommended anymore because, as you see, they get very dirty, and if it catches on fire, it's stuck to you, so we don't want that. If you are working in a special lab, they make flame retardant lab coats because these can be buttoned all the way up and protect you from chemical spills. Now the preferred method is to have a thick apron because the apron you can take off very easily if something spills on it. As we're moving down, I see that our lab assistant went and got a snack and has a drink and a sandwich. We do not want to ever eat in lab. What if we spilled chemicals or contaminated our chemicals or touched our chemicals and then ate our food? We would not want to ingest any of these chemicals, so definitely we are not allowed to have food. The last thing that we see down here is flip-flops. These do not provide any protection and can be a trip hazard. So we want to make sure that we wear closed-toed shoes, preferably something that will cover our legs as well, like long pants. So on our lab exercise, it says to list the lab safety rules that Mr. Bone has broken. You need to list each of those items here where he needs improvement, which is almost everything. And then what did he get right? Well, he is wearing goggles, but he hasn't been wearing them properly. So there's one item there. As we move to the next page, we're going to start to get to the experimental design section. Experimental design is important because it can help us find answers to our question. On our lab materials, you see one of the lab materials is something called a fortune fish. These are really cheap little party favors, but they're really cool. You can hold it in your hand, and as you hold it in your hand, it almost immediately flips over and starts to curl up. This is a behavior that we are going to try to explain today. So our question for our experiment is, why does the wish fish lay flat on the table, but when I put it in my hand, it curls up? That's what we want to answer. So the first thing here is the hypothesis. Our question is, why does the fish curl? Okay, we want to answer this question. The hypothesis says, why do you think the fish moves? Our hypothesis is going to be our best guess to answer this question. So to answer this question, you might think about the properties of your hand. What's going on your hand that is not happening on the table, because the fish will lay flat on the table. So as I think about my hand, I think it's warm, it's body temperature, but also there's a little bit of moisture, maybe some salt from sweat, maybe some static electricity, especially because it's cold this season. So I'm going to list all those reasons here. Any reason that I think the fish might move. Is it heat? Is it static? Is it salt? Is it moisture? What is the answer to this question? And I'm going to test all of these items. Next, I need to identify my independent variable. I need to focus on only one of these items because I can't test all of them at the same time, or I won't know which one was the right answer. So my independent variable, I'm just going to test one of these at a time. This is also called the manipulated variable. The independent variable is what you are changing about the experiment. So the first thing that I'm going to do is static versus no static. Okay. The next one I might do is heat versus room temperature. Moisture versus dry. And the last one, salt. Salt versus no salt. Okay. The dependent variable is also called the observed or the measured variable. This is what happens as a result of our independent variable. So this would be the fish curling. The last one is the control variable. We already said the control variable when we said versus. So in this case, it would be no static, or it's going to be a second fish that's not in the experimental condition. So we're just going to leave a second fish on the table, and that will act as our control. Last, it says experimental procedure and data collection. We need to plan our experiment. And in this, I want you to use as much detail as possible. You can write over these letters because they're gray, so they're not super visible if you write over them. But we are going to do the experiment. You can choose one of these items. You don't have to do all of these items. For the sake of the video, I'm going to do all of them. You could even come up with a different one that's not on this list. What do you think this fish might be reacting to? But you're going to write in as much detail what your procedure is. I have all of these materials on my table. I have water, I have a glove, I have a thermometer, I have a balloon, I have salt, and I have a hot plate, which I have set to low, but I'm going to turn off because it's actually pretty hot. The first thing that I want to test is static electricity. For this one, the procedure is very simple. I'm going to take a balloon, blow it up, and I'm going to rub this balloon on a carpet or my hair and produce some static electricity. Then I want to hold the balloon next to the fish to see if it reacts. That will be my experimental procedure. Whether or not the fish reacts will be my data collection. Okay, I have my balloon. I'm gonna produce some static. And my hair is standing up, so I definitely have some static. And the fish clings to the static, which is interesting, but I don't really see it curling and flipping and behaving the way that it did when it was on my hand. And now I see this fish, this is our control fish, not doing anything. So I would reject the hypothesis here for static electricity. I don't think that static electricity is what is causing the fish to flip and move. Next, I want to test moisture. So I'm going to create a condition that is moist and a condition that is dry. So I'm going to use the paper towels for this one. My procedure will be to have a moist paper towel and a dry paper towel. My control fish is on the dry paper towel, and you can see that it is not reacting. And then when I put my testable fish on the moist paper towel, that is a really similar reaction to what happened when it was sitting on my hand. So I might accept this hypothesis. Moisture probably has something to do with why the fish is reacting that way. And you can see if I lay it back down on the table, it will start to uncurl. The next condition is going to be salt. I am going to again use the paper towel, and I'm just going to put a little bit of salt on my experimental side and no salt on my control side. We can see the control fish is sitting flat. By now this fish has flattened out, and let's put it on the salt. I do not see any movement, so I'm going to reject the hypothesis. We do not think that salt has to do with this reaction. The last thing that we haven't tested is heat. So I have these two fish here. I have my fish that is control. It is not in the heat condition. And then I'm going to have my fish that is in the ooh, that was a very strong reaction. So I'm going to accept my hypothesis, and I think that heat definitely has something to do with why the fish is moving. Now, this is interesting to me because maybe at a different temperature, it would not behave the same. So we do have a thermometer which can test what temperature the fish is reacting at. But you see, it's already laid flat again. So it is a good reaction. Another thing that you can do to test for heat is to isolate your hand, the moisture from your hand, by putting on a glove. So now when I touch the fish, I'm only using the warmth of my hand instead of the moisture from my hand. I'm not seeing much of a reaction without that moisture. It is curling a little bit. Not very much, not the really fast, strong reaction that we saw with the water and the heat condition. So we think, let's go to the next page. Our results and conclusion, it says, what did you observe and was your hypothesis correct? So our conclusion will be that heat and moisture play factors in why the fish move. Okay, this one says confounding variables. We need to really look at our experimental design and see if there are any strong confounding variables that might affect the reason the fish is curling. In this experiment, for example, when I put the fish on the hot plate, there's electricity running through the plate, which may or may not be a confounding variable. I don't think it would be a very strong confounding variable. But also the fish is made of plastic, and maybe the heat is burning the plastic and it's not an actual mechanism of the fish curling. That can be determined by removing the fish and seeing if it lays flat again. It should lay flat again if it's not damaged, but if it's damaged, it won't lay flat again. And as we see, it's curling up quite a bit here. It's actually fun to watch. Let's take it, and as it cools down, we can see that it is starting to lay back flat. So I don't think that we're damaging the fish by heating it up, but it's definitely causing some curling. The next section is called experimental redesign. Now that we know that heat and moisture are the most likely causes and we've identified any confounding variables, we want to redesign our experiment to be perfect. We can list any items, not just the items listed here, anything that we think will make this experiment phenomenal. For instance, having a thermometer to measure the temperature and then trying several different exact temperatures to see which one causes the fish to react the most, or to measure the amount of moisture or the amount of water that we use and have different levels where we can see exactly what is affecting this fish. So this is a formal lab write-up where we have to have our materials and our methods. You're going to list your hypothesis, procedure, and the variables of your new experiment. In class, in face-to-face class, we shared all of our answers, and so we had 6 trials and we all shared our results, and we either decided to accept or reject the hypothesis. So we did this as a team, and the conclusion would be definitively, why do we think the fish is moving? So the actual mechanism of the fish is that it's not just one layer of plastic, it's actually 2 laminated, very thin layers of plastic. And so when you lay it on a hot surface or you put it on the water, it is affecting the layer on the bottom more than it is affecting the layer on the top. It's not made of regular plastic, it's made of something called sodium polyacrylate. This is a super absorbent polymer that can be found in diapers and also Orbeez. And what do you know about diapers and Orbeez? When they get wet, they expand, they grow. So imagine having 2 laminate layers and one layer is growing and the other layer is staying the same. This will easily start to cause curling as that bottom layer grows and expands. And then when it is no longer under that condition, it will go back to normal. So I want you to reflect on our hypothesis and evaluate how this experiment helped you understand the function of the fortune fish. And this process can be applied to any question that we have, which is what science is based off of. The last section is an optional section where we're taking a different experiment. Instead of using the fortune fish, we're going to measure the effectiveness of lactate. We're not going to physically do this experiment, but there are some questions on the quiz about this test called Benedict's test. So you can use this section to answer those questions on the quiz. Thank you for joining me for week 1 of Biology Lab, and I look forward to seeing you the rest of the semester. Don't forget to take your 5-question open note lab quiz, and don't forget to keep all of these lab handouts because the final is open note and you want to use all of these handouts to help you on the final.